Hey everybody, it's Miss Phoebus, and I'm back with another lesson, lesson 64, dot plots and stem and leaf plots. Alright, so we have to be able to represent data with plots on a real number line using various displays, and there are four that we have to talk about, and the two that we're talking about today are dot plots and stem and leaf plots, or sometimes they're called stem plots. And our standard for today is to represent single or multiple data sets with dot plots, histograms, stem and leaf plots, and box plots. We're going to be on page 323 in your notes, and when you get there, you're going to see a thing about dot plots. Dot plots are a type of data display in which each data item is shown as a dot above a number line. In a dot plot, a cluster shows where a group of data points fall, and a gap is an interval where there are no data items. So when we create dot plots, we want to order the numbers from least to greatest. Optional, but you need to know the min and max values. All right, you're going to draw a number line. You're going to label the number line with the minimum and the maximum, and then you get to make a decision where all the numbers that fall between them, how they're going to be counted. And you got to be careful though, because you don't need to be making two dots that look like they're right on top of each other when actually they should be next to each other. You are going to create a scale. So again, it's something that is going to be a little bit individual to you. So each dot plot is going to be a little bit unique. You're going to put a dot above each value on the number line for each data entry in your set. And you want to stack these as vertically as possible. All right, so here we go. We've got an example. Mrs. White took a survey of 10 ninth grade students. She asked each student how many items they recycle in a day. Below are her results. So we have 10 numbers, and we're going to make a dot plot to display this data. So we have from 0 to 5. They're already in order, so we don't have to know what the smallest is and what the largest is. They're already there. On your number line, your horizontal line, you want to make tick marks to represent each value. So you want them to be equidistant. You want them to be about the same distance apart. And I kind of put these 5 here, but we actually need 0, 1, 2, 3, 4, and 5. So I really need 6 lines. So I'm going to go ahead and put this one at the end. It's okay if there's extra line. It's just that you need to definitely make sure that these intervals are spaced out. So I want to see these tick marks because this shows the exact location of where the number is. So my number may be a little bit off. Look at 4. 4 is not directly under my tick mark, but my tick mark is going to be where 4 actually is. Now I'm going to come back through with my dots, and I want my dots, like the first dot, to all kind of be about the same. So you see how that 4 doesn't quite go up? I want them to all hit about the same level. So I have 1 0 in my data. I have 3 1s, 1, 2, 3. I have 3 2s, 1, 2, 3, and I want them to be pretty even. So I want the dots to kind of match up. So I might go back and do that one. 2, 3, and then 2 3s, 1, 2, no 4, so I leave that one blank, and a 5. Now, if I had more numbers, I might not write 4, or I might only count by evens. It just kind of depends on what your data set looks like. You may even skip count, but you got to be careful because you may have values in between the ones that you've marked with tick marks, and you want to make sure that you are indicating the right number. Now, we have, and this is not part of the dot plot, but this is something I want to talk about. We have a cluster here. And then right in here where 4 is, this is a gap. So that's just kind of the vocabulary that goes along with that. And then 5 isn't like a little cluster by itself. It's just kind of almost like an outlier, almost, but not quite. We wouldn't probably go that far. but it is kind of separated from the cluster group by that gap. All right, here's example 2. All right, so we have fuel economy in miles per gallon of 2015 model year vehicles. Okay, so we've got a whole bunch of data. We have, it's mixed up, so let's try to figure out the smallest and the largest. I think the smallest is 16 and the largest is 40. So we have to get the 20s, the 16, then the 20s, then the 30s, and up to 40. So I'm thinking that we might count by 2s. So if I do 16, 18, 20, and I don't like where that 20 is. I'll get a little bit closer. 22, 4, 26, 28, 30. Now, because I'm counting by 2s, I have a nice in-between spot. I have a nice in-between spot for my odd numbers to fall. So it won't be hard to figure out where those go. Here's 36, and here's 30. 38, and 40. Okay. And so I'm going to go through, and what I'm going to do this time is I'm going to mark out the ones that I've used, because when you get a little bit more data points, might lose track of what I was doing. So here is 16, and 27 is about right there. Notice I'm trying to line up 16, that dot from 16, and the dot from 27. So I'm not going to put it right on the line, even though there's a place to do that. I want them to be able to kind of all match at that same height. And then I've got a dot at 30, 31, 32, another 30. I got 2 more 31s. Actually, another 31. 24, about right there. And 40. And a 31, another, ooh, lots of 31s, and another 31. And a 32. And a 23. And a 29 right there. All right, so there we go. We've got a good cluster right in here. We have several gaps, even some big gaps like between 32 and 40, but we have a cluster. So we would say that most of our data is centered around 30, 31, 32 miles per gallon. And then we see we have a low end, we have an upper end, and so we are able to look at the data as a picture. All right, so let's talk about the shape of a dot plot graph. So when we look at the one on the top here, notice that most of the data is to the right, and then we kind of have this drift to the left of like slower, less data points to the left. So that would mean that it's skewed left. And when you talk about skewed, we always skew which way the tail is, and the tail is the piece that has the fewest amount of points going out. Not everything has a tail, but a lot of the data does. And what that skewed left means is that the mean is more likely to be smaller than the median. So the median might be somewhere in here, and the mean, that means we've got some lower numbers, might be pulled down when we look at those values. So because we have lower numbers kind of dragging that to the left, the mean would be smaller than the median. All right, if I look at the middle one, most of my data is on the left, so my tail is kind of going off to the right, and that means that it is skewed right, and the mean is more likely to be larger than the median. And then here, and it's not exact, but you see how most of the data is in the middle. We've got a little bit over here, we got a little bit over here. So we have symmetric, or even roughly symmetric. So symmetric means like, hey, everything's exactly the same on, one side and on the other. Or roughly symmetric, it's about there. And the mean and the median should be pretty close. All right, so here we have some different dot plots. So the one on the left is girls versus boys, maybe age or shoe size. I don't know. Who knows what it's about? We don't have that information. We're interested in what the shape of the data looks like. So if you look, we've got a very symmetric. Everything with the exception of my curve is symmetric about this data set. So we would say this is a symmetric shape. Okay, this one has more here, and then it's got its tail going this way. So we would say that this is skewed to the right, because the tail points to the right. Most of the data is on the left. The tail is dragging to the right. It's skewed right. All right, most of our number of cakes made, most of them are over here on the right. And then, yeah, we have 4 that say 1, but we have a smaller data set than this big chunk that we have over here. So this is going to be skewed. And the tail points to the left, so skewed left. All right, so that's pretty much it for dot plots. You need to be able to make them. You need to be able to recognize if there is a cluster or a gap. And then you also need to be able to talk about the shape. Is it symmetric? Is it skewed left, skewed right? All right, for stem and leaf plots are an arrangement of digits used to display and organize a set of data. It's a different way to look at them. And so what I want to draw your attention to here is we have a stem. And this stem is usually the tens digit. Not always. Sometimes it could be a hundreds digit, but usually it's a tens digit. And then we have these leaves. These are typically the ones digit, but not always. We could have a ones digit as the stem and a tenths place, like a decimal place, 1 decimal place, as the leaf. So it just kind of depends on the data set. But notice here, and this is very important, we have a key. And so the key is basically going to tell you how to read a stem and leaf plot. And so what they're saying here is if you take the 6 here and the 3 here, which is what they have, right? They have the 6 and then they have this bar, and then the 3, that translates into 63 years old. So then now you can read it. 1 and 0, that's 10. 3 and 2, that's 32. 0 and 4, that's 4. And so you have to be able to not only make them, but you also have to be able to read them. The one on the right is a back-to-back stem and leaf plot without a key, which is really bad. But basically what this is going to be our tens digit. And I'm not 100% sure. But when you get here, there's our tens digit. When we get here, this ends up turning into the hundreds. Okay, so if we are looking at this right here, and let's say we pick this, the 13 and the 6, that's 136. Let's assume pounds, okay? I'm guessing. It could be 13.6, but again, we don't have a key. With the left side, so the boys, when you read, it's very similar to the stem and leaf plot that we just looked at. But with the girls, you're going to have to read it backwards. So this 16 and the 7 is not 716, it's 167. So you have to throw the leaf at the end behind the stem. So with our back-to-back stem and leaf plots, you need to be careful and you need to make sure certain things. As I go from left to right on this side, my numbers increase. As I go from right to left, my numbers increase. So there's some differences there, and definitely this one would be so much better if it had a key, and you are going to be required to have a key so that I know what numbers I'm reading. You know what numbers you're putting. We're going to look at the shape of stem and leaf plots. So this is a good one for rotating if you actually had the printed page. Rotating it and looking at it like the graph of a dot plot, you may want to kind of turn your head a little bit. But what you can tell is you can count each of these as a dot. Like there's 1 dot here, 2 dots here, 3 dots here, or if you were looking at this sideways, remember, 1, 2, 3, 4, 5, 6 dots, and 4 dots, and 3 dots, and 2 dots, and 1 dot. So I'd say this is very, very symmetric. This one has more data points on this side than it does on this side. Here's my tail. So it is skewed to the right. This one has more data points on the right, and it has a tail over here. It's skewed to the left. Okay, so with a stem and leaf plot, you can still describe the shape of the data. It's just you may have to rotate some things or turn your head a little bit in order to see the values and the shape come together. So when you look at a stem and leaf plot, there's no magic way to tell what the mean or the median or anything like that is. You have to look at the individual data sets. So you may want to break out the graphing calculator. We need to first be able to read what's going on. So which age occurs most often? Here's our key, and they're telling us that when we see a 1 and then a 0, that means we have a 10. So we actually have 2 10s. We have a 17, a 24, a 26, a 32, a 33, a 34, 3 41s, which I find very interesting, a 40, I just wrote on top of that, a 43, a 53, 2 56s, and a 59. So our age that occurs most often is 41. What is the range of ages of the hikers? So that is going to be pretty straightforward. We want the biggest number, which happens to be 59. And we want to subtract away 10. That gives us a range of 49. Now, what is the mean age of the hikers? We're going to take the average. That's going to be the best thing to do. All right, so you can stick it in the calculator, all of that, doing the data stuff that we were looking at in the last video, but pretty much this is all we need with this data set, so I'm just going to average them together. So I've got 10, and then a 43, and then a 53, and then I'm going to divide by, there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, divide by 16, and I get a mean age of 36. Okay, and so being able to read the data plot is just as important as being able to make one. So I also think that being able to read them before you can make them is also important. So steps to creating a stem and leaf plot. You're going to split up the digits of the numbers into a stem portion, usually the tens digit, depends on what you kind of have going on in your data, and a leaf portion, usually the ones. This will vary based on the number types that are in your data set. Then you're going to order the data values in your stem and leaf plot from least to greatest. Then you're going to generate a key using one of your data values as it looks in the stem and leaf plot and what the value represents. Without this, the stem and leaf plot is difficult to read. So you need to make sure you provide a key. How to read this. So here we go. In 1 month, you earn the following daily amounts. So we've got numbers in the teens. We've got single-digit numbers. We've got numbers in the 20s. Okay, and that looks like the most that we have. So what we want to do is we want to have an idea of how many things we have, because there is a chance that we might run out of room. So I do want to show you what happens if you need to maybe bump it to the next level. So let's see, we've got 1, 2, 3, 4. So we've got 4 single digit, 4 ones. We've got, I'm going to do this in a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The teens. And then we have 1, 2, 3, We have 3 in the 20s. Okay, so we've got quite a few in the teens. So I want to show you what to do if like you need to almost like overlap and try to create this again. So what we're going to do is we are going to first start with a stem and a leaf. So we're going to label that, and you want a vertical line separating the stem and the leaf. And what we're going to do is we're going to put a 0 to represent the ones, a 1 to represent the tens, but we're going to do 2 of them just because we've got a lot of numbers in the teens. And then we're going to do a 2 for the 20s. Okay, we want these in order from least to greatest. When we get to the ones, we're going to basically do, and this is not part of your stem and leaf plot, but we're going to do 10 through about 14 in that line, and then we're going to do 15 through 19, and that puts about 4 to 5 in each, 4 to 5 numbers in each of those rows. Everything else will need to be in order from least to greatest. You do not want to mix those up. And you can separate them with commas. You don't have to. So it's kind of, that's a personal preference, but you want to make sure that those numbers don't really run together. All right, so let's see. We've got 9, 9, and 6. So I'm going to do 6. I like the commas. I think that it makes it look a little bit nicer and easier to read. And then I'm going to remove those from my data set. All right, do I have any 10s? I don't think so. I have an 11. And then I have a 12 here and here. So I need another 2. And here. So I need another 2. And I think I got all the 12s. And then I've got 1, 2 13s. So 2 3s. And then a 4 for the 14. Now, if you wanted to keep going and have one really, really long stem with a leaf, you can. This just kind of helps conserve space just a little bit. All right, we're going to jump to 15, and we've got 1, 2, 3. Ooh, I forgot an 8. 4. So I'm going to go back and put in 4 of these 15s. And I'm going to go back and fix this. I forgot an 8. It happens. So it's not like I'm just going to tack that 8 on at the end. That's like a no-no. You don't do that. That's why I'm even making that mistake and not going to be cutting that part out of my video, because I need you to see that. All right, so I think I got all my 15s. I think that looks good. I've got 2 17s. 1, 2, 7, 7, and then an 8. And then I think that's it for my teens. And then I've got 2 20s and a 25. So 0, 0, 5. Now, I'm not done because I have to make my key. So we're going to come through here. We're going to do key, and we're going to pick one of our data values. Doesn't matter which one. I am going to pick this one right here. And so I'm going to do 1. And then I'm going to do a vertical bar, and then I'm going to do a 4, and I'm going to state what it equals. And I'm going to actually put my units in there, $14. And that's it. That's your key. You don't have to do the one where you separate it into the 2 rows, not necessary. But if you find that it is something that you need to do, that's how I would do it. I would do 0 through 4 in one row, 5 through 9 in the other row as needed. But each stem gets its own row. And then you need to make sure that you organize them from least to greatest, going from the stem out. All right, so in a skating competition, a figure skater's technical marks were, and there's a whole bunch of them, make a stem and leaf plot to display this data. Now this one's a little bit different because we don't have 10s and 1s, we have 1s and 10s. So what we're going to do is we're going to do the 1s place as the stem, and then the decimal point as the leaf. So I've got 0, and when I do have 0 and there's a gap, I'm going to make sure that I indicate that one. All right, so we're going to have our stem, we're going to have our leaf, We're going to start at 0, 1, 2, 3, 4, 5. Now, even though we're not using the 1 and the 2, we're going from 0 to pretty much 3. We are going to still include those to show that there is a gap. Because remember, in our dot plots, which we looked at the stem plot being kind of like the dot plot, we want to show that there is a gap. And if I just jump from 0 to 3, somebody that looks at it might not think that there is a gap. So I've got 0, 0.0, which is a terrible, terrible score, 3.5, and 3.9, 4.0, and then I've got two 4.1s, and a 4.3, and then I've got a 5.0, and a 5.5, and a 5.8. And then that means I've got everybody. Okay, and then I'm going to make my key. So my key, I'm going to pick one of my data points. Let's do 3 and 5. There's 3.5. And we don't really have, I guess they're points. We really don't have units. Now you don't have to underline them in the stem and leaf plot. I'm just showing you which value I chose. But you could have used 4.1 or 5.5. Just indicate what that number actually means outside of the stem and leaf plot. All right, here is our back-to-back stem and leaf plot that shows the number of calls made in each of 2 police departments in the last 14 days. So we are going to need to find the mean, the median, the mode, and the range of each department. We are going to also answer the question on average, which police department receives the most calls, and then we are going to learn how to read a back-to-back stem and leaf plot. So what I'm going to do here is I'm going to set this up. Department A, Department B. I want mean, so I want X bar. I want median. I want mode. And I want range. All right, so that should be able to fill that in. And we may be able to tell the mode. The mode is the one that happens the most. So in my key, I see here the way that this is written, that's actually this chunk right here. And so when I read Department A, that's going to be 32. So we start with the stem and we go to the left, that's going to be our 1. For Department B, we're going to read this as 31. The 30 is still in the stem, it's the 30, and then the 1 represents 1 digit. Okay, so let's go ahead and get the mode for Department A. We want the one that happens the most, and I see 3 8s right here, so that's going to be 58. All right, let's look at the mode for Department B. I see 3 2s right here, so that's going to be 52. Now, the mode doesn't necessarily mean that it's going to end up getting the most calls like Department A automatically wins. We're going to look at the mean and the median as well to figure out on average kind of what is the center of that data. All right, the range is going to tell us how far that data is spread out. So because I'm dealing with mean and median, I want to go ahead and put this in the graphing calculator like I did the other day. And this would be good for you to practice, right? More practice with your graphing calculator is a good thing. And so what we're going to do is I'm going to put Department A in L1 and Department B in L2, and I'll run them separately. All right, so I hit Stat and Enter, and then I'm going to fill in Department A at 32, 35, 39. And you gotta be careful because Department A is the one you're reading backwards. So it's really easy to turn this 1 and 4 into a 14, but really it's a 41. So that's why I want to spend time doing a back-to-back, because they do get a little confusing sometimes. We've got 52 and then we've got 3 58s. And then a 61, a 62, and a 63. And then we have none in the 70s, but Department B does have some in the 70s. So we'll come over here and we have for department B, we have 31. And you have to pull that stem and leaf together. You can't just do the leaves. You have to pull them together into one number. 50, 52, 2. So I've got all my data in. And now we're going to do stat, write 1, and I want to do it on L1. That's department A. So my mean is 49.64. And my median is 50. And my range is 63 minus 32, that's 31. So they're 31 apart. And then we're going to do stat, right? And we're going to do one variable statistics, but we want to change that to L2. So second and 2, we'll change that to L2. And then we've got a mean of 51.86. And we have a median of 52. And we have a range of 71 minus 31 is 40. Okay, so let's look at what's going on here. So we've got a higher mean for department B. We have a higher median for department B. Our mode for department A is higher, and our range for department B is higher. So if we're looking on average which police department receives the most calls, because of these two, I'm leaning more to department B because they have higher end values. The range is just going to show me how far away things are spread out, and we may even have an outlier. I'm not 100% sure, but that does pull on the mean a little bit. It is close to the median, however, so I don't think it's pulling way too much on it. Okay, so we're looking at two different locations, daytime temperatures in degrees Fahrenheit of two different locations in the past 15 weeks. So we have location A, we have location B. We have a key that tells you what's going on, and we're trying to find mean, median, mode, and range for each location. On average, which location has a milder temperature? So we want somebody, or we want a location that has lower temperatures than the other one. So I want you to start looking at, can you pull this data into the calculator? So I want you to pause the video and work on getting location A into L1, location B into L2. Pause the video now. So what I have is I have location A into L1, location B into L2, and we're going to compare them. So we've got stat, right, 1, and now I got to go back and change L1, second, L1. All right, so we're doing mean, median, mode, and range. So we've got A, we've got B, we're going to do mean, median, mode, and range. Okay, so for A, we've got 78.5, and then let's get the median, 79, and then the range is 91 minus 67, which is 24. Let's see if we can pick up a median or a mode. Let's see if we can pick up a mode. Looks like we've got two modes. We've got 2 3s here and 2 0s here. So you are allowed to have multiple modes. So we're going to have 83 and 90. Now you don't want to go like, I have 5 modes, but if there are a couple that do have the same number of repeating values, you're allowed to have multiple ones. I'm thinking for location B, 66, there's 2 6s. So 66 is the mode here. And go back to our calculator. I'm going to have stat and right, and 1. Right, change this to L2. And we've got 75.93. I'll scroll down. The median is 75. I'm feeling location B has a milder temperature, and then max minus min, and this is just more kind of practice for you, 26 for those values. So because of these, and maybe even the mode, we have multiples in the 60s, I would say that location B has a milder temperature than location A. So that's just kind of pulling all that stuff together. Then you can do mean and median and mode and range from these because you can see the number values. And we're going to talk about later on that in some of our graphical displays we can't see them. So we won't be able to figure out the mean and the median, the mode, and even possibly the range if we do not have certain, if we don't have the data set. So that's it. And if you are going to have to create a back-to-back stem and leaf plot, just remember that when you start here and your stem is in the middle, you're going to be doing least to greatest as you go from right to left. So you might think it's greatest to least, but you definitely want to organize those numbers if you have to make a stem and leaf plot that's back-to-back. You do not want to make two separate ones. It's easier to compare them if you have them back to back. So you can kind of see this one's got a little bit of a tail. It's skewed to the right a little bit. This one's roughly symmetric. So you can compare them that way. All right, that's it for this video. I hope you're doing well. We're counting on the days to the end of the course. There aren't too many left. I hope you've learned something in this class. I really do. I know that I've been tough on you, but I'll go ahead and let you know I would have been tough on you mathematically wise if you were in the classroom as well. So don't think that I'm being extra tough on you just because you're virtual. We would be doing lots and lots and lots of things in the classroom. So, but I appreciate you sticking with me. All right, I will see you guys in the next video. Bye!